Hello dear, how are you? We have given a curve y square is equal to 8x. It is a curve which is symmetric about x-axis. Since power of y is an even number, therefore you can say that curve is symmetric about x-axis. Its name is right open parabola. Y square is equal to 8x right open parabola, and we have to find the area. First of all, we have to find the area, green portion area. We have to find green portion, and then we have to find the area which is red shaded. First we find green shaded area, and then we find red shaded area, and then we have to add these two areas, and and we have to check whether total area is equal to the area of rectangle OABC. First we find green shaded area. To find the green shaded area, we can use the formula. For green shaded area, we use the formula integral from 0 to 2 y dx, because limits of integration we take from x equal 0 to x equal 2. We have to find the area under the curve, the arc of the curve. This is an arc of the curve. When we use the limits from 0 to 2, x equal 2 is the ordinate or vertical line. We take limit from x equal 0 to x equal to 2 and use the curve y is equal to 8x. The arc of curve will be this. Area which we will get, this will be the green portion area. We take limit from 0 to 2. For green shaded portion area, for green portion, area will be equal to 0 to 2 y dx. We use formula y dx because limits of integration are the values of x coordinate. When limits are given in terms of x, we use the formula y dx. We write 0 to 2. Value of y from this equation we get by taking square root under root 8 under root x dx. Under root 8 taken as a constant, 0 to 2 x raised power 1 by 2 dx. After integrating, under root 8 x raised power 3 by 2 by 3 by 2, and its limits from 0 to 2 we get 8 multiplied 2 by 3. After applying limits, we get 2 raised power 3 by 2 minus 0 raised power 3 by 2. We get 16 by 3. Sorry, under root 8, 2 under root 8 multiply 2 raised power 3 by 2, can write 2 under root 2 minus 0. We get the required area 2 under 2 multiplied by 2, we get 16 by 3. Green shaded portion area will be equal to 16 by 3. We now find red portion area. For red portion, for red shaded For red shaded we use the limits. When we want to find the area of red portion, we use the limits which are the values of y. We take y is equal to 0 to y is equal to 4, because 2 or 4 is the point which is lies on the curve. We take value of x, for example x equal to 1 to x equal to 2, and when we put x equal to in equation of curve, we get y is equal to 4. At this point, coordinate of b, point B lies on curve, its coordinate x equal to and y is equal to 4. At this point, value of x is 2 and value of y is 4. Hence, we take the limits of y-axis. We take y equal to 0 to y is equal to 4 to find the red portion area. We use y is equal to 0 to y is equal to 4, and we use the formula for red shaded area, limit from 0 to 4, x dy, and value of x from given equation, which is equal to y square by 8, we take 1 by 8 as a constant, 0 to 4, y square dy 1 by 8, its integral y cube by 3, 0 to 4, which is 1 by 8, applying limits, 4 raised to power 3 minus 0 raised to power 3, we will get red shaded area will be equal to 64 by 8, 64 by 24, 64 by 24, we write 3 multiply 8, 24 as a constant. This area this is red portion area and this is green portion area. When we add these two areas, we can check that total area will be equal to the area of rectangle OABC, and area of rectangle OABC, width of rectangle which is 2, and length or height of rectangle which is equal to 4, and area of rectangle which will be equal to length multiply width, width 2 multiply width 4, 2 multiply 4 will be equal to 8 square meter. Area of rectangle will be equal to 8 square centimeter, and we add these two areas. Green area plus red area will be equal to 16 by 3, which is our green portion area, and red area which will be equal to 64 by 24, 64 by 24. When we add these two areas, we get which will be equal to 8, and we can see that area of rectangle which also will be equal to 8 square centimeter, and sum of these two areas which also will be equal to 8 square centimeter. Hence, in this example, we use both formulas to find the areas. This formula we use when limits of integration in terms of x are given, and we use other formula when limits of integration in terms of y are given, we use this formula when limits of integration in terms of y are given, and we use this formula when limits of integration are given in terms of x.